Creating a corridor from an assembly. Welcome back. In the previous lesson, we built a complete assembly, a two-lane urban road with curbs, shoulders, and a daylight slopes. Now, we will bring everything together and create a 3D corridor model. In this lesson, we will learn how to combine an alignment, profile, and assembly to generate a corridor. This corridor represents the full 3D roadway model that can later be used for surface creation, quantity analysis, and visualization. Understanding corridors. A corridor in Civil 3D is a dynamic 3D model that follows an alignment horizontally, a profile vertically, and use an assembly to define the cross-section. It's the heart of roadway modeling, allowing Civil 3D to automatically generate surfaces, sections, and volumes. Creating a new corridor. Let's begin by creating the corridor. From Create Design, select Corridor. In the dialog box, enter meaningful name as Main Road Corridor, and from here in Alignment and Profiles, select Alignment 11, and Profile Layout 7, and Assembly, Main Road Assembly, and make sure the target surface from here is existing ground. Then click OK. Placing the corridor region. Civil 3D now creates a corridor region along your alignment. Each region is defined by start and end change and uses one assembly. If your road design changes, for example, a wider sections or different slopes, you can later divide the corridor into multiple regions. From here, assembly is main road and start station 0 to end station at 4,300 meters to the end of the alignment, and in frequency. By default, the corridor creates cross-sections at regular intervals along the alignment. These are called frequency. Here, adjust the interval between sections, for example, 10 meter. Frequency to apply, click here, and along tangent for horizontal baseline, select 10 meter for smoother modeling, or 20 meters for faster processing. Then click OK. Assigning targets. Sub-assemblies like daylight or sidewalk may require targets to connect property to the existing surface or specific feature lines. Open target from here and assign an elevation as existing surface from here, and for the lane super elevation to the left, and here the super elevation in right, assign as existing surface. Also here as in urban replace sidewalk. Select existing surface, and in offset select alignment also, and here alignment, then click OK, then apply and OK. Rebuild the corridor. Now the corridor dynamically adapts to the terrain as shown here. This is our corridor from top, and here viewing the corridor in the 3D. Let's visualize our corridor. Open the object viewer Here, select, then right click and object viewer. Change it to considerable. Then zoom to corridor. And you can change visual style, for example, to realistic. Then you close it. Notice how each subassembly forms part of the surface, lanes at 2% across the slope, shoulders existing outward, and daylight slopes blending into the existing ground. Creating a corridor surface. A corridor can also generate surface automatically, perfect for contouring and volume calculations. Right-click in corridor and choose corridor properties, like this. And in surfaces, select data type, link, and specify code as top. Click in create corridor surface and name it as top surface. And click OK. Civil 3D now generates a surface that represents the top of the pavement. Corridor editing and rebuilding. One of the most powerful features of corridors is their dynamic behavior. If you modify the profile, alignment, or assembly, the corridor automatically updates. Save your project to pre-save corridor model. You will need it for the next lesson, where we will extract cross sections and create corridor surfaces for analysis. Thank you for watching. See you in next lesson.